Hi, in this video I'm going to show you two ways we can minimize a DFA. Method 1. We have three steps in method 1. Step 1 tells us which states are dead or inaccessible. In this automata we have none. Step 2 shows us the transition table I've drawn over here. And step 3 we divide it into different partitions. In P0, we have A, B, D. These are the non-accepting states and these are the accepting states. C and E are accepting states. So we've got two groups over here, right? Next, we see A, we check the input of A and input of B. Over here, we have in input of A, when we input small letter A, it goes to B. And on B, on capital B, it goes to C on input A. So we check whether B and C are in same groups. They are not. They are in different groups. Therefore, we divide them. We put A in one group. Then we check whether D is in the same group as A. We check the input of D. On A, it is C, B and C. Are these in the same groups, B and C? No, right? So we put A separately. Then we check whether B and D are in the same groups. On input A, we have C, and on input A for D, we also have C. Then we check B. We have the same inputs for B and D. Other than same inputs, these inputs are in the same group. Let's check. We have C and E in the same groups, right? Therefore, we put B and D together. Then we check for C. On C, on input A, we have B, which is in group 1. On input B, we have E, which is in group 2. So we separate C. Similarly, we do the same for E. We separate E. Why? Because on input A, we have E. It goes to E, which is in group 2. And on B, it goes to E, which is in group 2. That's why we make a separate state for E. Then we do the same over here. Now, since the last process, or let's say last step and second last step, we have the same states, therefore, this is going to be our final minimized form of DFA. Subscribe or see through my channel for method 2.